Okay, so we have our next example. We want to evaluate the tangent of the arc sine of 3/5 minus the arc cosine of negative 5/13. So remember, when you do an arc angle or an inverse, or an arc sine or an inverse, this is going to give you, this is the arc sine of a ratio, which is going to give you an angle. Okay, so now we have another one, the arc cosine of a different ratio. So this one's going to give us a different angle. So we'll call the first one theta, and we'll call the next one alpha, because I'm better at drawing those than the little squigglies. So what we're really dealing with right now is tangent of theta minus alpha. So the tangent of theta minus alpha equals, this is one of the formulas that you've already memorized, right? Because you've been working so hard. The tangent of theta minus the tangent of alpha over 1 plus tangent theta tangent alpha. So you can look at the yellow sheet, or you can look back at the beginning of the notes that gives you the formulas. So this is the formula right here that we're dealing with. So we need to find what the tangent of theta and the tangent of alpha are. So just like the last one, we are going to draw triangles. Arc sine, positive arc sine, is going to be in the first quadrant. So here's your triangle for that one. Here's your theta. Sine is opposite over hypotenuse. Oh, this is nice. It works out to be one of our special right triangles, a 3, 4, 5 triangle. So that one is easy to do. Next one, we have our alpha. This is arc cosine, and it's negative. So remember, arc cosine can only be in first or second quadrant. Since it's negative, it has to be in the second quadrant. And then cosine is adjacent, so negative 5 over hypotenuse. This is another special right triangle. So if you remember this one, it's a 5, 12, 13 triangle. If you don't remember it, you can do the Pythagorean theorem and get it. So this is my alpha angle, and the green is my theta angle. So now I need to do the tangent of theta minus the tangent of alpha. So tangent of theta is, we're looking at the green triangle, and the tangent is opposite over adjacent. So the tangent of alpha, sorry, that's blue. Let's go to green. All right, tangent of theta is 3/4. And then we also need to know on this blue triangle what the tangent of alpha is. Alpha, which is 12 over negative 5. Oh, it doesn't want to write 12. There, 12 over 5, and it's negative. So then we'll plug it into the formula. So you have 3/4 minus negative 12/5, so that turns into a plus 12/5 over 1 plus 3/4 times negative 12/5. We need to get a common denominator to add these. So on the top, our denominator is going to be 20. So this is 15 over 20 plus 12 times 4 is 48 over 20 divided by 1 plus, go ahead and multiply these. I don't want to reduce it, even though I probably could. But if I don't reduce it, then I'm going to have this denominator of 20 just like I have in the numerator. And that's going to make it easier when I'm flipping and multiplying and all that. So I have 12 times 3 is negative 36. So I'm going to make this a minus. Minus 36 over 20. 1, right? If we have a common denominator of 20 is really 20 over 20. So I'm going to go ahead and write that on there so that I have it. So 15 plus 48 is 63. 63 over 20 divided by 20 minus 36 is negative 16 over 20. Now, when I'm dividing, I can just flip it and multiply. So I have 63 over 20 times negative 20 over 16. 20s will cancel, and you get your answer is negative 63 over 16. And that's it. Okay, so we have another example, kind of like that, but this one is where we have the x's and the y's in there. So again, this is just going to be, this is the inverse sine of something, which is just going to give you an angle. and then the inverse cosine of something else, which is also just going to give you an angle. So we're doing cosine of, over here, all right, we're doing cosine of theta plus alpha, which is cosine theta cosine alpha minus sine theta sine alpha. Okay, so we really need to memorize these, so it helps if you write them all out every time. We'll draw our triangles. Inverse cosine, or sorry, inverse sine of 2x is going to be opposite over hypotenuse. So this is going to be, if we do the Pythagorean theorem, 2x squared plus b squared equals 1. B squared equals 1 minus 4x squared. So b equals the square root of 1 minus 4x squared. Because the x and the y are on the top, the quadrants are going to be right no matter which way you do it. So we're not going to worry about if x is positive and if x is negative, putting them in the right quadrants. We're just going to deal with quadrant 1 since it's going to be in the right quadrant. All right, so that's our theta triangle. And then we need to do our alpha triangle. Inverse cosine, so is going to be 3y over 1. So this is going to be the square root. We'll do the, just like we did the other one, of 1 minus 9y squared. So you could have done the Pythagorean theorem and gotten that just like we did on the blue one, but it works out the same way. So now, cosine of theta, so we're going to do the blue first, right? Cosine of theta is adjacent over hypotenuse. So that's square root of 1 minus 4x squared times the cosine of alpha, which is 3y over 1, minus the sine of theta. So we're looking at the blue triangle again, 2x over 1, which is 2x, times the sine of alpha. So that's the square root of 1 minus 9y squared. Okay, so looking at that, you can't multiply outside of the square root to inside of the square root. So the left side, we just have 3y. I'm going to put it in front because it's better to read. Times the square root of 1 minus 4x squared minus 2x times the square root of 1 minus 9y squared. And that's all we can do with it. So that's your answer. You can't multiply anything in. They're different roots. You can't combine them. You can't square root those because they're not perfect squares. So those are the answers for that. Okay, so this time we're going backwards. So we have sine of some angle, cosine of a different angle. We'll do x's and y's just to make it easier. So we have sine of x, so we're going to say that x is 20 degrees and that y is 40 degrees. So we have sine of x cosine of y plus cosine of x sine of y. And we're trying to get this in exact form. So we're in the expanded form. It goes sine, cosine, cosine, sine. So that's the sine formula. And its sine follows the same signs as the equation. So this is sine of x plus y is sine x cosine y plus cosine x sine y. So again, you can have your formula sheet in front of you while you're doing these, but it's going to be a lot easier if you start trying to memorize them and you can recognize it instead of just looking at your formula sheet, because you're not going to get one for the test. So, so we're in this form, right? Sine 20 cosine 40 plus cosine 20 sine 40, and we're going to go to this form. So this is just sine of 20 plus 40 degrees. 20 plus 40 is 60, so sine of 60 degrees. And we know that on the unit circle, the sine of 60 degrees is, hopefully you guys already have this before I tell you, but it's root 3 over 2. So that's